Hello everyone, welcome back to Chapter 6, Part 5. We are going to see how to construct the Consumer Price Index. Here is an example. So step number 1 is survey the households and fix the consumer basket. So previously, I showed you how they survey the households with that booklet, enter it into the database, and then find out the average amount of consumer goods that the consumer consumes. So average is typical. So that's why in the consumer basket, it is a typical American consumer who consume that amount of consumer goods and services. So there are thousands of them in the basket. I just want to pick out 2 as an example, so to make life easier, right? Okay, so assume that the amount of pizza in that basket is 25 pizzas, and the beer that people drink is 100 cans. Well, I just make up the number so it's easy to calculate, okay? All right, so let's assume that there are only 2 products that is in the consumer basket. Step number 2 is to record the price. The Bureau of Labor Statistics actually will go out to the market and write down the price of pizza. So that must be in the same spot. So, and for the same brand of pizza, same size, same everything. So just assume that they recorded down it was $10 per pizza for 2004, and then in the next year, the same pizza, same location, same everything, for that pizza is $11 for 2005. And as for beer, $5 for 2004, and then $6 for 2005. Okay, so this is how they record the price. Next, we're going to calculate the cost of the basket. So cost of the basket means that how much money does it need to buy this amount of pizza and beer, which is in the consumer basket. So for 2004, we just use the price multiplied by 25 pizzas. That will get the cost to buy 25 pizzas, and then $5 multiplied by 100 beer, and that will give us the cost of buying the beer. And then we add the 2 expense up, and that is the cost of the basket in 2004. So $750 is the cost of the basket of 25 pizzas and 100 beer. Okay, now next, let's calculate the cost of 2005. Can you do that? Pause the video and see if your calculation is the same as what I got. Okay, so what do you got? I got $8.75. Is that what you get? Good job, very good. So now we have the cost of 2004 and the cost of 2005 for that consumer basket. Next, we are going to calculate the consumer price index. The formula for consumer price index in year N is the cost of the basket in year N divided by the cost of the basket for the base year multiplied by 100. N stands for a particular year. For example, if you want to calculate 2004, then N is 2004. 2005, then N is 2005. Okay. By the way, every time when you try to develop an index, you multiply 100. Okay. So now let's let the base year be 2004, and let's calculate consumer price index for 2004. So we're going to use the cost of the basket in 2004, which is $7.50, divided by the base year. Base year is 2004, so divided by $7.50. Okay. So 2004's cost of the basket $7.50 divided by base year it's the same. So multiply by 100, what do you get? 100, isn't it? Very good. Now, can you pause the video and calculate the consumer price index for 2005? Very good. So calculate it, and before we move on. So what do you have? Do you get 166.66666? Oh no, sorry. It is 116.66666, right? So if we do a rounding, don't keep any decimal place. That is going to be 117, right? Very good. Now that we have the consumer price index, we can compute the inflation rate. Inflation rate is, in fact, the percent change of the consumer price index. So as long as that is a price index, for example, GDP deflator is also a price index, we can always find the percent change of the two deflators, and then we will find the inflation rate. So the formula is inflation rate in year 2 equals to price index in year 2 minus previous year, which is year 1's price index, divided by price index in year 1. So this is year 1, this is year 1 also. Remember that, okay? All right, so let's see how to calculate consumer price, the inflation rate by the consumer price index for from our example for 2005. What do you think? It should be price level in year 2, which is our 2005, which is 117 minus previous year is 100, right? And then divided by 100, multiply by 100%. Let's see what we got. So yeah, that is 117 minus 100 and divided by 100 times 100%. What do you have? 17%, right? Very good. Question. In our example, is it possible to compute the inflation rate of 2004? Why? Let's see. In order to compute the inflation rate for 2004, we need 2003, isn't it? This is 2004, so we need 2003. However, we didn't have 2003. So the answer is no, it's impossible because we don't know 2003. Okay? Okay, let's do an exercise. Compute inflation rate by GDP deflator. So this is given to us. Can you compute inflation rate for 2013? Okay, pause the video, compute it, and then we compare the answer. Okay? So, do you get 2%? Very good. If you get that, yeah, I got 2% also. So this is how to calculate it. Sorry for the handwriting. I use mouse, so it's so hard to draw. Sorry. Now this chart shows the inflation rates. One is calculated by consumer price index. The other one is calculated by GDP deflator. So the GDP deflator is the black one, this one. And then the CPI one is the purplish looking one. Okay, so now let's take a observation. See, there are two. Are they looks similar? Is it similar? Very good. So they show the similar tendency. When one is in increase, the other one is also increase. For example, say during 1973 to 1975, see both of them increase, right? And after that, both of them decrease. And then both of them increase again, both decrease. So they move towards the same direction. Okay, that is one. Are there any difference? Can you see the difference between the two? One move more than the other, isn't it? The consumer price index, which is the purplish one, it fluctuates more than the GDP deflator. So yes, the rates of CPI vary more than the rates of GDP deflator. The reason for CPI to vary more is because consumer price index includes food and energy that is in the basket, and food prices and energy prices usually fluctuate a lot more than the other good. While GDP is consumption good, investment, government spending, and export. So because it covers more goods and services, and those broader measure is more stable, even though it also includes the food and energy. But because it includes all the other goods, so it becomes more stable. However, both are good indicators of inflation because it moves ups and downs almost at the same direction most of the time. That said, we notice that CPI is not a perfect measure of the cost of living. The consumer price index has some problems. These problems include substitution bias. You all know that if the price of a good goes up, people buy less, right? So when the price of pizza goes up, people buy less pizza. However, the basket is fixed. We use the same amount to measure the price change. So because of that, it's not a perfect measure of the cost of living. The second problem is it excludes new goods, because during the time they do the consumer survey to form the consumer basket, those new goods are not there yet. And now the new goods is available out there and people spend money, which is the cost, to consume that good, but it's not in a basket. So that cost is not being captured. The third problem is unmeasured quality improvement. The goods in the basket, their quality keep changing. Most of them goes up. However, CPI only measure the change of the price. They can't measure the quality change. So that is a problem too. The last topic for this chapter is Phillips curve. It puts the inflation and unemployment together. Phillips observed that in the short run, if the inflation rate is high, unemployment rate is low. If the unemployment rate is high, inflation rate is low. So in the short run, if inflation is high, unemployment tends to be low, vice versa. And this is Phillips curve. So in the United States, usually if the unemployment rate is around 5, which is the natural rate of unemployment, then inflation rate is usually around 2%. Okay? All right. I'm going to stop here for this part, and I'll see you in the next part to talk about the exercise, classroom exercise. Okay? All right. Bye.